Manoj. I am here to discuss about the objectives of water treatment. And before knowing what exactly the objectives of water treatment are, we should know what is water treatment as well as the necessity of treating the water. So we know that there are three essential things for the existence of human creatures or human beings. Those are clean air and good food as well as clean water. If these three things get polluted or contaminated, then it will affect the existence. So keeping this in mind, so let us move on to the concept. First, let us know the objectives of environmental engineering. The first objective is to supply water to the public in sufficient quality as well as in adequate quantity. The very next objective is to collect the wastewater generated and to treat it and to dispose it and to manage the solid waste generated and to manage the air quality. It might be indoor or external, and to manage the industries. In industries, we need to manage the environmental systems over there. So, these are the objectives of environmental engineering. As per the water treatment and supply engineering concerned, I am concentrating on first objective, that is water supply and treatment. So if you consider this, there are two things very much important, that is quality and quantity. The question popped out: what is quality as well as quantity and quantity? So quality, if you take the quality into consideration, so if the let us say if the water is get polluted, if water contains pathogenic bacteria, that means it will cause waterborne diseases. That means our country will the country's productivity will be decreased, so that we need to maintain the good quality water. So if you take quantity into account, then government of India recommended that for the high maintenance of the hygiene and the basic needs, people need 135 LPCD per day that should be supplied. So for the design of water treatment schemes, we need to consider water quantity very much. But when water treatment is considered, quality plays a very important role. So for that purpose, let us discuss about the quality in depth. So I would like to say that in earlier days, uh, there was the awareness was more on quantity, but recent days we are more aware of quality aspect. So let us go in depth about the quality of water. If you look into the history, there were references made in Sanskrit literature, that is Indian history. If you take Indian history long back 2000 BC, there were references for maintenance of the quality of water. So in that, people were boiling the water and filtering the water, and we all know that we still have this practice of using copper vessels. That means if the water is stored in the copper vessel, copper will get discharged into the water and it will have some bactericidal effect which will kill the bacteria. There are references in Greek Roman literature also. They were using the wick siphons. That means they will have two containers. They will put a siphon cloth, so from one container, the siphon, the cloth will absorb the water into the other container, so that the sedimented or settled particles will be in the other container, fresh water will be in the other container. These are the quality aspects maintained in the past. So the system consists of settling operations followed by filtration, put in service in 1804. Until then, there was few practices, but exact picture came into this on 19th century, commencement of 19th century. That is, usually they were having the practice of maintaining these things. Only they were having these things. Nowadays we have advancement in treating, but those days we have only two basic things, that is settling operation as well as filtration. In mid 19th century, that is Dr. John Snow correlated disease with water quality. I will say that this is the breakthrough in before the germ theory exploration. That means he correlated the disease with water quality. This is the first time people correlated disease with water quality. The first permanent installation for chlorinating water was made in Belgium. So and so far there are many advancement have been uh, coming nowadays. I can say that even today the quality of water plays a very important role and a challenging thing for us as an environmental engineer, water engineer. Even today as well as in the future, quality of the water is a challenging thing, as because you can see, I can say that there are advancement in detecting the pollutant. Earlier there was no possibility of determining pesticide as well as insecticides, but now we can detect those, so that we should detect those. As we are detecting them, we should remove them from the water. So as the advancement of detecting is going on, the quality or maintaining the quality or treating which will also improve further. Yes. Let us know the attributes or characteristics of drinking water by considering this statement given by the UN General Assembly, that is right to water. In right to water, they say that the human right to water entitles everyone without discrimination to sufficient, safe, acceptable, physically accessible, and affordable water for personal and domestic use. That means we should supply the water to people without discrimination, having these things in consideration. If you group these things into one thing, that is we can characterize this into three categories. That is, first thing is aesthetic. That means water which we produce or water which we will be supplying to the people should be free from the any turbidity. That means in a physical perception it should be odorless and colorless. If you take safety into account, then it should be the water which we will be producing should be free from the pathogens as well as toxic chemicals like heavy metals. And economic means, economic category says that if the water we will be producing, it should be it should be at a reasonable cost. So whatever the water we will produce based on the beneficial uses, it should be it should contain these three attributes. Then we can say that if the water has these three attributes, if it is aesthetically acceptable, it is safety, and it is economical one, then we can say that the water which we are producing is potable as well as palatable. So suppose, let us take for an example, uh, we are about to supply water for a community, or we are about to treat a water for a community, treating water from the source, and we are supplying it to the any community. So first thing, before setting up the water treatment facility, uh, the first thing that will come into mind is where exactly we will draw the water from. That means what is the water source for the city or the community. So there are many water source we have known since long back. That is, seawater is a source actually, precipitation or else rainwater, river water is also a source, groundwater is a source, lake water is a source. So let us take seawater into account. It contains salt. That means salinity as well as TDS will be more in this. So if you want to use this water, we need to remove these salts or salinity and TDS. That means we need to adopt desalination units. So if you take precipitation or rainwater into account, we should remove gaseous vapors and particulate matters. So river water, if you take river water into consideration, I can say that this is the most polluted source of water, as because all along the stretch of the river, it will take pollutants from nowhere in any point. That means it will be polluted by the untreated wastewater discharges, and it will be polluted by the agriculture runoff too. That means majorly it contains turbidity as well as pathogens. So it can be grouped as it will contain particulates, organic matter, nitrates, and phosphates, biocides. So before using the river water, these things should be considered and should be removed by the treatment. So if you take the groundwater sources into consideration, here two things come into picture. That is, it will be we may draw the water from the shallow wells, or we may draw the water from the deep tube wells. If you draw the water from the shallow wells, there you will get pathogens, as because the shallow wells will be recharged by the surface water, so there might be chances of contamination. So if you draw the water from the deep tube wells, there will be no pathogens, but they may contain inorganic salts as well as iron and manganese. So these are to be considered while using groundwater. If you take lake water source, it acts as a natural sedimentation tank, as because of the lack of turbulence, algae will be grown there, and it contains odor and taste. So before using these sources, we need to consider the pollutants in them, and we need to decide the extent of treatment that should be given. So I would like to discuss with you people some more things in front of the blackboard. See you there. So as per the discussions made in the slides, we came to know that the quality of the water and the extent of treatment needed will be depend on the source of the water which we draw from it. That means the extent of the treatment as well as the quality of the water will be depend on the source of the water which we drawing the water from, as well as the point of intake. That's what we came to know from the slides. So next, say for example, we need to supply water for community. Suppose the source might be river. So river might be the source. Assume this as a river. So from this, we need to supply water to the community. So the very next question is, up to what extent we should treat the water? The extent of treatment should be known. So the extent of treatment, I will mention it as let me write it full. Treatment will be depend upon two things. That is, it will depend upon water quality and it will depend upon the beneficial use. So here the beneficial use might be domestic, it might be industrial, and it might be recreational purpose or etc. It might be any beneficial use. So for each beneficial use, we have to treat it for certain extent. So the extent of treatment will be explained or given by as per the guidelines given by WHO. So based on the WHO guidelines, each country will develop with their own standards. As of India concerned, we have BIS to set standards. We have our own IS codes, which will set the allowable limits for particular parameters as well as pollutant and contaminants in the river water, or the extent of treatment should be given to the water before supplying it to the beneficiaries will be given in the IS codes. So this is how the extent of treatment is known based on the water quality, and for this extent we will treat the river water and we will supply the water to the domestic purposes or any beneficial users. So far we are discussing about, or we are about to know what exactly water treatment is and why we need water treatment exactly. So in this point of view, we need to know there is a collaboration between water treatment as well as wastewater treatment. We need to know this. In order to understand this collaboration, we need to know these two terms, that is pollution load as well as carrying capacity. Okay, pollution load is nothing but the anthropogenic activities, products of anthropogenic activities, that is exactly waste which we produce and feeding into the environmental sinks. Carrying capacity is the self-curing capacity of the nature. Okay, so now prior to industrial revolution or a green revolution, the pollution load was earlier, the quantum of pollution load was earlier very less when compared to carrying capacity. It was like this, but nowadays due to urbanization, industrialization and increasing population, this equality is reversed in a drastical way, that now pollution load is very much greater than when compared to carrying capacity. So we as environmental engineers and water engineers, our concern is to change this inequality. That's it. We need to bring it back. We need to increase the carrying capacity. It's not in our hand actually. We need to decrease the pollution load so that carrying capacity itself can treat it on its own. So carrying capacity, particularly it is only on biodegradable matters, but nowadays we are giving pesticide, insecticide into the environment. It couldn't be treated here on its own, because it is a conservative pollutant, which we will be discussing. Based on the nature of the pollutants, carrying capacity depends. So as I said, as an environmental engineer, my concern is to reverse this thing. So what we do is, we observe the reactions, we engineer this process, the self-curing capacity which we observe in nature, we engineer this process, and what we do is, we increase the rate of reaction. Or else we amplify the rate of reaction. Along with that, by increasing the rate of the reaction by observation, we make it happen in a limited time. As well as in limited space. This is what we consider as water treatment. So in order to say we are treating the water, that means we are observing from the nature itself. We are learning from the nature. That's why I love this subject. That means we are learning from the nature. We just amplify the rate of the reaction. We will do it in limited time as well as in limited space. That is what concerned about. That is what we say
water treatment. So if you observe closely here, you can see the collaboration between wastewater as well as water treatment. That means if you take, suppose the pollution is entering to the river, if you let the carrying capacity itself treat on its own, it might take 100 days, or 100 days it might take 100 days or 1000 kilometers to treat on its own. But as an engineer, my concern is I should make this happen in 10 days. That means I need to reduce the distance of this capacity, and I need to reduce the time. That means I need to make it happen in 10 days. As an environmental engineer, my concern is to reduce the rate of the reaction, or increase the rate of the reaction, and reduce the time. Within limited time and within limited space, I need to obtain this quality. That's what, as an environmental engineer, I am concerned about. As I add on to the understanding of water treatment as well as wastewater treatment, I am very much interested in explaining this graph to you people. So before explaining this graph, I need to say you people that purest form of water is rainwater before it is entering into the atmosphere. As soon as it enters the atmosphere, it will mix with acid mists. As soon as it touches the ground, it will be mixed with many solids, or a pollution load will enter into it. That means it will enter the rivers. That means at the starting point, the quality, let me explain this graph. The vertical axis resembles the quality, it will say the quality, and the horizontal axis, it might be time or it might be distance. So initially the river will be having this much quality. Imagine it is having this quality. So as along the course of the river, the quality will be decreased. You can observe the slope. The quality will be decreased, as because the contaminations or pollutants may enter naturally or anthropogenically. So this is river water quality. As I already said that each country has its own standards for any treatment or any beneficiary use purposes. So in that point of view, let us take for drinking water, the quality might be here. So drinking water quality that should be supplied to the consumer should meet this quality. The water which we supply to the consumers, it should have this quality. So that means, suppose city X is intended or interested in drawing the water from here along the course of the river. It is clearly resembled here, it clearly shown here that this much amount of treatment has to be given. That is, it shows that extent of treatment that should be given to the river water in order to supply, if we draw the water from here. And also the city X also produces the wastewater. The wastewater also should be dumped into the river water. That means the quality of the wastewater will be somewhere below the wastewater. Actually, it will be here. So in order to keep the river water quality in very well manner, in order not to disturb the river water quality, we need to treat this river. That means wastewater treatment plant has to be set. If the wastewater treatment has not set, then what happens? If the wastewater fed as it is into the river water, then what happens? The river water will definitely purify itself on its own based on the carrying capacity of the river, but it takes time, and in this zone the water quality will be deteriorated in very bad manner. Suppose, my question is, there is a city B which is intended to take the water from here, which is a very nearer point actually. That means if the city people want to draw water from here, they need to treat this water to this extent. You can see here. That means the extent of treatment is increased. If the extent of treatment increase, the cost of treatment will increase. So if we not preserve the water, if you not protect the water, if you not give the first line of defense to the water sources, this is what happens. If suppose, imagine, if the wastewater treatment is given here, given over here, that is wastewater treatment is given over here, then the river water quality remains the same, then the extent of treatment will reduce. So this is the collaboration between water treatment as well as wastewater treatment. This is what I am intended to tell you people. You might have wondered why this fellow is explaining all these things just to distort the objectives of water treatment, but these things has to be known from you, known by you. So in further slides, in PPT, I will going to explain you people. I have grouped the things and I have listed the objectives of the water treatment. There I will discuss with you. Thank you.
Welcome back. So far we came to know what exactly water treatment is and why we need the water treatment. So taking these things into consideration, I have listed the objectives of water treatment. The first and foremost objective is to collect the water from the best available source. Before setting up the water treatment plant, we need to select the source. That is the one of the major objective of the water treatment. So next thing is, the major thing is to remove turbidity as well as pathogens. We should consider this. I will put this as star thing, because while designing the things, while designing the treatment units or unit process or unit operation, these things are considered. Means I should remove turbidity, I should remove pathogens. Then I can say I am producing potable or palatable water. This is the major objective of the water treatment. Then to provide adequate treatment to make water potable and as well as palatable, as I said, to meet the water quality standards, as I discussed in front of the board, I should meet the water quality standards set by the regulator authority, and also to prevent potential problems caused by inorganics or impurities, such as in the form of suspended solids, in the form of dissolved solids, or in the form of pathogens. So last thing is, I should assure the quality of water. That means when water treatment is considered, I am not only treating the water, I should assure the quality of water. That means it should not be stored more. The water, what the treated water should not be stored in the containers in for long period of time, and the disinfection should be given while we distributing the water, so that it should not contaminate while distributing the water to the community. So that is, along with the water treatment, we also assure the quality before sending it to the public. Now I will end this session right now. So these are the references I have gone through to prepare this content. So thank you for watching. So we will meet in the next session. In next session I will be discussing about the population growth as well as population forecasting. So until then, stay tuned, stay at home, stay safe, study at home. Take care, bye.